Well, welcome to class, Miss Childs.
Good morning, Mr. Tyler.
Welcome to class, Mr. Gray. All right. Missing Adam Bagardo. Jacqueline Camacho's absent as well. I just saw Eli last period. What happened to him? He's not present. Courtney's not present. Frida Johnson's not present. Gabriel's present. Leah Mims absent. Angel Ocasio absent. This is before class started, so give them 5 more minutes. So that's officially about to start. Everyone else up Mark is getting extra credit for arriving early, so thank you.
Hello, Mr. Tyler.
Sorry, what was it? Oh, okay. So Leah's arrived. I guess he said he's coming right back. Gray's missing. Okay, that's what happened.
Hey, Mr. Tyler. Mr. Tyler. Mr. Tyler.
Can you hear me?
Yeah, well, it's kind of been a definite film. So I won't be here today.
Okay, understood.
Um, yeah.
Well, thanks for letting me know.
If you got any further questions, you just call my dad, man.
Okay.
All right.
Mm. All right, 1 minute, everybody. Let me get started. Okay, welcome to class, Jacqueline. All right, let me mark her present. Okay, so we're about to get started with our norms, and then we're going to discuss today's uh, evaluation, which is assignment, and it's in SB. So let's get these norms out the way. Okay, I'm gonna go down the list. Let's make this a little bigger for everybody. Okay, 5 basic norms. Miss Mims, can you read number 1 and number 2?
No one has the right to hurt another education. I mean, no one has the right to hurt another person, education, in the classroom, or sacred.
You raise your hand.
I already said them.
Oh, you had raised your hand. That's why I was confused. All right, 3 and 4. Jacqueline, can you read that?
We will never behave in a way that will discredit ourselves, our school, our family. At Excel Academy cells our students. That's always a later agenda.
Thank you. Okay, 5 and number 1. Kylie, can you read that?
We take pride in Excel Academy of Southwest.
And the number 1 there too.
We respect the opinions of others.
Thank you. So next up, just going back to the top, is 2 and 3. Aaliyah, can you read those? Aaliyah, are you there? Okay. So I'll read those, I guess. We respect the opinions of others. We respect the culture of the class. No, no. Sorry. 2 and 3, right? We respect the culture of the classroom. We are attentive and participate. Let's see here. Gabriel, you there?
We have high expectations of ourselves, our school, our peers. We are here focused on preparing ourselves for secondary endeavors.
Thank you, sir. All right. I want to make sure I got him as well. You raise your hand, Miss Childs. Do you have a question?
I was trying to read number 5.
Oh, it's okay. We have more to read before we get started. Appreciate your zeal. Okay, so let's get started on today's assignment. What you want to do is make sure you're logged into your SB account as well as your Google account. And got the townhouse link here. We're going to come down to today's assignment. Put this in the chat. Miss Childs, you'll be able to read it if it fits for 25 points. Let me see if it fits though. Oh, it chopped some of it off. Hold on. What's ball at? Okay, at 8.6 meters, right? That's what it's missing. Yeah. Okay, so can you read what's in the chat and put in the last bit in there?
Please remember that all synchronous problems need
You,
to be
you skipped
completed.
hello.
Huh?
Skip the whole hello part.
Oh, hello and good day to all the future physicists.
There you go.
Please remember that that all synchronous problems need to be completed and ready to present tomorrow in class. Asynchronous problems have to be completed as homework and will be checked tomorrow in class as well. A bowling ball moves with constant velocity from an initial
Initial, yeah.
initial position of 1.6 meters to a final position of 7.8 meters and 4.558 seconds. What is the position time equation for the bowling ball at the time is what time is the ball at the position 8.6 meters.
Very good. Very good. All right. So what we're going to do is we're going to now start our Google Doc, right? So let's do that. That's going to be, let's see here. Come here and click on our Google Apps. All right. So now all I'm gonna do is establish a new document title. So that'll be due now, right? And I'm gonna put the rest. So today's date, so the 23rd. I think we only got 2 days this week. You all. 23rd of November, today and tomorrow, and then it's Thanksgiving. I guess you guys are off. Okay, so next is our header. Let's put this all together and in perspective. So that'll be your name. Like I'm typing mine, but you type yours. The date is 23rd. It again. Next is going to be what? Well, don't forget the period we're in. So that'll be, make sure it's right here. So that period is second, because we're in physics. You guys are physics with algebra students. Okay. So who knows what the title is? You can raise your hand if you think you know. 15 points if you can tell me what today's title is. Oh, Miss Camacho, go ahead. You raise your hand the fastest.
What's the equation of motion?
Thank you. Very good. So yeah, her 15 points. So let's type that in there. What? I'm taking it straight from Esby. That's where she found it, everybody.
So Big Mom like, should we do it this?
Sorry, Miss Childs. Okay, I thought you had, I thought you had a question. I'm gonna center this in our exit slip, right? That's real simple. So your exit slip, classroom, composed of classroom term of the day. And don't forget the word of the day is required, but not just the words or the terms. You need the definitions of these. So word of the day is, okay, so what was it? So classroom term of the day is in the brackets, right? So let's come back and look. Inside the brackets, I have position. That's your term. Next is the word of the day, and I think that was substantial from what I saw in Townhouse, right? Come down, and then next we need our two questions. One is the 1S is your in-class one. We can do that together. And then you have your asynchronous problem. It's the one we're going to do separately. So let's come here, and I'm going to grab these two questions and put them into my document. You should be doing the same. So there's both questions. And you should have this much so far, if you've been keeping up with me, as far as what you're going to share out in a moment. So the questions, 1S are synchronous, and 2A, that's the end, when you're at home and you're trying this out on your own problem, right? All right, so now that we have that at least done, we can start investigating how to actually calculate things. Okay, so I think everybody's caught up. Now I'm gonna start typing the notes in here. I'll put the notes in the chat as often as I can, but just try to pay attention to the setup. So the first thing you want to think about is, how do we calculate, or what is the position time equation of motion? So that is this, is type it here for you. So position, name of the equation you're going to be using. We're going to put these notes in the center. Time equation. And this goes right in the center. And what is that composed of? Well, and from physics books, these is considered kinematics, or equations of motion. So the first thing is you have to understand final position. This will be denoted as XF is equal to your initial position, right? And you have, it's going to be plus the velocity, we talked about velocity last week, multiplied by time. Okay, so that's going to be time. And I'm going to say elapsed time so you don't get confused. So elapsed time, so that's the time that's passed. Velocity, these are all elements of the position time equation. So you have, I think this is the introduction to motion section we're in. We'll set it up like this for you. All right, next, we want to talk about how each of these is measured. So final position is measured in meters. Equals initial position, which is also measured in meters. Plus, velocity is measured in meters per second, right? And this is multiplied by time, which is seconds. Finally, what do we need to use when if we have to do some algebra, if we have to set this up for our known and unknowns, we have to set it up in terms of a mathematical representation. So that'll be XF, and yes, you have to edit the same way I'm doing it. So XF is equal to XI, which was plus, we're going to say lowercase v multiplied by t. That's a mathematical representation of such. So I'll put parentheses right here so you can see the differences. And you're going to subscript the I and the F here because that's how it's designated in science. So it's mathematically correct as a be denoted. All right, and then F is going to be subscripted as well. Awesome. So now we have our equation, a mathematical representation. We can start setting up our known values and our unknown values. Okay. What do we get? Well, let's go to our problem and pick this apart slowly. We're talking about 1S, the very first problem. And this is a similar problem for your homework problem. This is going to be a point where I want to see how many people can get this part done because these are similar problems. I just changed the numbers a little bit. So known values, what do we have? It says a bowling ball with constant velocity from initial position, hint, hint, an initial position. Look at our equation and our terminology. Initial position is xi. So I'm just going to grab it from here because that's initial position. So I'm just going to grab this, come down to knowns. I probably got to center it, bring it over. There you go. It matches up. Turn the subscript off. I can see it still down there. There we go. Equals what? They gave us initial position of 1.6 meters. All right. Everybody's keeping up. And then this goes to what? A final position. Let's XF, right? Let's grab that. Come down here. And that's XF. Turn this off. And that's equal to, what do we have there? 7.8 meters. Okay. Now they also give you time if you look there. So that is basically 4.58. That's T. So let's come down here. T, I think it's lowercase t in most cases in physics, is equal to 4.58 seconds. Okay. What else? Well, what's unknown here? Well, one, your velocity, right, which we can use algebra to calculate using this equation here. And that's going to be meters per second. If you don't remember the dimensions, it's right above in our notes. And next, they want something else. So this is part A. They're asking for in part A. Down one. Can I do it that way? Do it this way. And here, this is part A. They want the position time equation, which you see above. Part B, they would like what? Let's say at what time? You can figure out time based upon velocity. So that's why I say you need, in this next component, the velocity to figure out time. You gotta solve it here first. So let me grab this. Treat it as a constant velocity. Okay, so what's needed here, and this will be just seconds, right? want you to understand is all going to be part B. Oh, let me undo that. I didn't want to remove that. So unknown position time equation. And then here, this is part A. Let me just come over. Make sure you know that. Part B is asking for time. Part B, you solving for time. I'm sorry, velocity, that's right. So T equals what now? Question mark seconds. All right. So you should have that much. Let me slow down and put this in the chat for everybody so you can start editing your notes correctly. So recap, these are all the initial notes. Now, when we go into using the position time equation, we're just plugging values in and then we're going to do some algebra to solve it. So here's what you should have so far. Shared it out in the notes a moment ago. Now that we have that, and these chat transcripts that's in the chat will be available in Edsby in your library section. Okay, so come down. Strategy is now what? Well, we're doing part A, right? We got to first set the equation up. Position time equation they're referring to. And this should be real easy if you're looking at it side by side with your known and unknown values. So how does that look? Let's just go through it slowly. Use strategy. Use the position time equation above. And I'm just going to take the position time equation. This here, the mathematical representation. And we'll start plugging values in, you know, and I told you we have some things and some things we don't, and what we don't, we'll solve for using algebra. So I'm going to center it, I'm going to left align it, and grab it one more time, and we're going to start plugging values in, because that's all it's asking you to do. But what you don't have, you leave the same. So basically, xi was what? That's 1.6. Let's put this in parentheses. So it's 1.6. I'm taking it straight from our known values, everybody. And then what was xf? Well, xf, if you look above, was, let's put this in parentheses, that was 7.8 meters. Okay. Next is time, and that was 4.58. So I put it in parentheses because we're going to put stuff in there later. And this is seconds. All right. So now we have what they're saying is this is basically part A. Put it, make your, you show what the position time equation, what is the position time equation for the bowling ball? So it's this. And we can't put nothing in V because we don't know it yet. And as I said later on, we have to solve for it. But V is needed for part B as well to solve for time. There's going to be a new time value we're going to do algebra on to find. So you're going to do algebra twice. I hope you're paying attention. First, we got to get V by itself to solve for that. Then we're going to use the same equation with V installed, but we don't know what the time will be. So we're going to solve it again. So let's get through the steps because it's 10:34. So what do I do? This is part A. And now for part B, you're going to, strategy there is to solve for velocity and then solve again for time, both by using algebra. Okay. Welcome back, Gabriel. Okay. So what do we got? Come down one, and I'm gonna just take this equation. This equation here, I'm not gonna, manipulate it with the values in it yet because that's gonna be difficult. Meters over here and seconds over there. So we're just gonna solve it this way. We're gonna put this here. And the goal is to first get everything around the velocity to the other side of the equation, other side of the equal sign, like right by the xf. So to do that, I would need to first remove anything that's being plus or minus into this side, right? So I can do the opposite of that xi. I can say, well, instead of plus xi, I'm going to do minus xi because I'm slowly removing things to the other side. All right, so it becomes this, and this is the actual change. Oh, I should have did that in the next step. Let me do that in the next step because let's stay consistent with you all. Grab it, come down one to here. Now, what did I say? We're going to say minus, right? And then it's xi, right? And I'm going to change the color of it so you can see the differences. So from above, you see it's black with the red changes, and the next iteration or step is what I'm doing algebraically. Okay, so that's a change. And then what you do to one side, you got to do the other, right? So let's grab this over here. And now we have this unique new situation I got to clean up. All right, so we're going to turn that off for a second, and then it's going to be plus, right? It's still minus. It's just that's the way you would set it up algebraically. So next steps, what happens here? Well, some things are going to cross out, right? Let's show what crosses out. Okay, they out there jamming. All right, so let's do this. And what crosses out? Well, I told you already, this xi and that xi, they're going to annihilate each other. So strike that out. And then when we come over here, we have this xi and that plus symbol, they go away as well. So you have a new equation, going to clean up, and then we're getting very close to our velocity being by itself, right? So let me fix this up for you guys. Okay, now take this down one, and we're going to rewrite the equation now. So we end up with what? Well, we know that this xi is gone, right? And we know this part is gone. Okay, so maybe I can zoom in some more so you can see these changes. Okay, so now we still don't have velocity by itself. This is what you call a multi-step algebra problem. The next thing is you see velocity is multiplied by t for time. So to get rid of that, we do the opposite multiplication. We do division, right? So let me come here, make this all black so you see it's about to have some algebra work on it. Come down one, and then next, like I said, I'm just going to put this back, but we're going to make some changes to it. Grab this, down one. And yes, I'll put this in the chat in a moment, but it's a lot of steps because we still got to go back and solve for t in time. So I'm going to put parentheses around these two because we're about to divide this whole thing. So grab that. And then we have this. Now these are the changes. All right, so that one and this one. And you end up dividing by what? By what you don't want, which is your t, right? You're trying to first get velocity so we can figure out the rest. What you do to one side, you got to do to the other. So I'm going to grab this and come over here. Turn that off. And put some parentheses around these because this is going to be divided out on both sides, right? Let's fix that. Oops, that was wrong. This one. And then over here, there's a parenthesis. Now it makes mathematical sense. All right. So now some things cross out. Get through it. Making good time too, by the way. 10:39. We get out of here 11:10. So we're almost through with this. So now, I hope everybody's following along because you're going to have to share out in a moment. T is going to cancel out. Cross it out. Because t divided by t is 1, right? Time divided by time, it's just 1. Cross this out and cross this part out. So now the new equation, if we rewrite this, is just going to simply be, come down one. All this is going to be gone and just v is going to be by itself. Now it makes sense. We can plug the numbers in and get our velocity, and then we still have to go back and figure out what t was using this same process. So I'm going to do that with you in a moment too. This is all black. And you see basically what it looks like now, where t is going to divide into the initial and final positions. And don't forget it's negative. So let's put the values in and get that by itself. Oh, Well, I'll put the values in now and then put it in the chat for you guys. So you come here. Here, we're going to start putting numbers in. So now the new equation for just the velocity is, where are we at? So we said it's xi, right? Xi is a negative xi, so it's going to be 1.6 meters, if you remember. So plug it in. Put this in parentheses too. So it was like 1.6 meters, right? Plus xf. Well, what was xf? That was a 7.8, I think. Yeah, 7.8 meters. So put that in parentheses. So 7.8 meters. And it's kind of cool thing about Math Pop is you guys can do this. Everyone can do this inside of the calculator. You have to look at the fractions and get all, we like, whoa, what's going on? Time earlier that they gave us, we're using that still, 4.58. And we're only doing this to find out the velocity so we can find the new time. That's not what I wanted you to do. Come here. So time is 4.58 seconds. And this is how we get meters over seconds, because meters are going to combine. And let's just clean this up so you'll see. All right, so meters are going to combine to 1, because those are like considered like terms if you look at it this way. And we get a new equation that looks like this, right? It'll be this. Seconds here and meters above, they'll combine and make meters over seconds, which is what we wanted for velocity. It's meters per second, by the way. And these meters will combine. So I'm crossing them out. They're like terms when they're put together first and then divided. Make sure you follow the order of operations. So parentheses, please excuse. That's why I use a lot of parentheses. All right, so what comes on the outside of this? It's just meters per second, right? Now we clean the equation up. So I can get rid of this, right? We just have the raw numbers in that. Okay. So now we just got to make sure we do the negative 1.6 plus the 7.8, then divide it by 4.58. All right, let's math pop of that. All right, so all of this jazz is going to be gone, right? We're about to calculate this one. Let me grab this and then grab Math Papa so you can calculate it. Because the very last one, I'm going to do the steps with you, but you're going to have to calculate the final answers. So copy this. And I want to jump into the next part, but you need these notes, right? So take your time and make sure you're editing that correctly. So the next part is what? Well, it's simply, you go to Math Papa. We're going to side by side this real quick. All right, so what am I calculating? Let me put this in here. Okay. And let me grab this in case you forgot it. Okay. Now just type in, use parentheses like I did. So parentheses, it's going to be divided because I want it to be a fraction like that. And I'm going to say, hey, I want to divide it by doing parentheses first, nested parentheses, 1.6 plus 7.8. Those parentheses come down 1, and then it's just 4.58. Okay, close parentheses. All right, so that's about 1.35 is a velocity, 1.35. So let's plug that in. Meters per second. That's the velocity, but we still have to do part B, which is solve for time now. Up here, and remember, we now have a velocity we can use to solve for t in seconds, right? So let's do that. If we come here and use the same equation, but now solve for, velocity, right? I mean, I'm sorry, for time now, a couple things change. So let's change it based upon the steps given already. And you can fly through that. So let's just re-edit this. Remember the strategy here, solve for time using algebra. And that's that lowercase t in our equation. Okay, so what does that look like? If I put this back here and we look at it, this is, we can't do it that way. So let's do it slowly. And I'll come up. It starts actually up here. Okay, so I'm gonna grab this. And it's almost the same procedure as the first couple of steps in this part. So what do we start with? We are still getting xi to the other side like we did last time. But now instead of solving for, like I said, v, we're solving for t. So let's clean this up. This is the new equation, right? Let's copy that. These are the actual correct steps. So this is the new equation when everything's crossed out. We did this part already. Now we want to get t by itself, right? So instead of dividing by velocity, all right? Instead of dividing by t, we're dividing by velocity. So let me just put the changes here. Wait, that's beforehand. I'm supposed to put the step beforehand, right? There we go, that's better. So you can see the changes. So from iteration to iteration, it looks like this. I'm gonna group these together and divide by what we don't want next to it. Okay, so let me fix that. Over here, fix this. And do that. And this will be divided now by what? I said velocity, right? Because we want time. We know the velocity, we just calculated that earlier. So what you do to one side, you gotta do to the other. So we're gonna grab this here as well. And don't forget the unit parenthesis over here to group it. So everything is divided by the velocity. Okay, so far so good, right? Now let's start crossing things out and finishing this problem off. We're almost through. It's 10:48. So velocities cancel, right? Velocity divided velocity is 1. And then we're gonna get rid of this. So what you have now is a new situation where all of this is pretty much gone and it's all just going to be equal to time. Now we have the part where we can just put our values in, right, and finish it off. Okay, so what does that look like? Let's put the numbers in, and you all are going to have to calculate the final steps, okay? Well, let's get that over with. I'm going to grab this. I'll show you what to cross out too, by the way. So what do we have, right? Well, I'm going to just save us some time. So t is now equal to, here, we got this situation, right? But it's not going to be 455 seconds in the bottom. So let me just grab this. And I'm taking this from the known values, right? One change is the velocity we now have. So if I look at this, it's negative 1.6, that stays the same. 7.8, yeah, but it's a velocity down here that we just calculated. And that velocity was 1.35 seconds. Things cancel out. Oh, not seconds, meters per second. There we go. Okay, better. Now meters and meters on the bottom, they're going to cancel, and seconds are going to come upstairs and be in the numerator. So it will have seconds in the end. Let's cross some things out. What crosses out, like I said, all of this is going to get canceled out and leave seconds on the outside. So we'll start crossing those out. And these are like terms in the parentheses. So they just combine and cancel with meters on the bottom. Right, and then, like I said, these two are going to combine. And same with this. Going away. I think we'll have enough time for share outs because we got here 11:10 and it's 10:50 and we're just about through with the problem. So let's rewrite this. It's going to be on the outside just seconds. Grab this and clean it up and see what our final answer is going to be, which you all are going to calculate. All right, so I can get rid of this, get rid of this, and get rid of this. So let's see what that final answer would be. You can use Math Papa to find out what this final answer will be. Type it in correctly though. And I think I'm gonna slow down for about 5 minutes and we're gonna do share outs. Okay, so if you need to scroll up, scroll down. Oh, I didn't put this last step in there. So where did I leave you off at? The velocity and that. You're missing this part. Okay, so from here on down, see if that fits into chat for you guys and gals. Okay, so well, you didn't get the final answer. You guys got to calculate. All right, so 5 minutes, right? And then we're gonna do share outs. See who got what done. Leave that screen up. I know people are like, can you go back? Then leave it right here. If you need me to go up or down, you guys gotta let me know though. You got more than enough to get that problem accomplished. So asynchronous problem is very much similar to the other problems. So you gotta go through and use those same numbers, not same numbers, but some same techniques. Man, I did a lot of work for you already to solve for asynchronous part or homework part. Everything is due by 8 p.m. tonight. I see a raised hand from Gabriel.
How you get that background
What background?
behind you?
Oh, man, I don't know. I did something in the settings, and it's a new feature, like with the raise hand feature they just gave us. Let's see if I help you out with that. If you click on your settings list, it says change background. You don't see that? So it's the three dots right before present.
Yeah, I see it.
All right. So that's something new. I don't know. It seems like it's working well because I know a lot of people don't want to show their house, and as long as I can see you in the camera with the background, I don't mind. But if you got a background that's covering you up and I can't see you, we gonna have a problem. So just choose the right one and something clean. Choose nothing negative. I think that was the only question on the floor. Oh yeah, I see he's flipping through them, and now you got your own kitchen in the background. All right, you cooking. Okay, so Okay, we're ready for share outs. Who would like to share first? Okay, go ahead, Jacqueline. I saw your hand. You stop sharing so it could work without. Sometimes that interferes with y'all sharing. Okay, so you got the floor. There you go. Wow, you've really been working at it. And she's got it edited right. Okay. Okay. So all you got to do is just your exit slip and finish up the homework problem using the same method. Turn in by 8. You are free to go. Who's next in the list here? Who's that child? Oh, Gabriel jumped up there. Okay, Gabe. You got to center your notes though, but overall, pretty good. And tackle the second problem. Okay. All right. So you're free to go, sir. Let me see who's next. Got Miss Childs and Aaliyah. All right, are you ready to share? There she goes. Okay. Okay, let's see your document. Oh, okay. All right. You got your notes spaced out a little bit there. Okay. Oh, there they are. I'm like, where the rest of them? Okay. So don't forget to put the second problem in there and give it a try, okay? And calculate that final answer too. Leah raised her hand, or was that Rush? Who's that? Somebody raised their hand, looks like. Oh, that's Leah. Okay. All right. Yeah, I was gonna say turn that sideways, young lady. There you go. Awesome. Oh, that's a good sight. Okay, so don't forget to calculate the final answer for time, and then don't forget to also go back and at least do 2A.
I will.
Okay.
All right.
All right. So the only change they should have made was 8.6. I was just doing that. Oh well. I just want them to understand algebra. Rush, you be there? Or?
Yeah, I'm here.